Hi everyone, welcome to today's webcast on cloud versus on-prem security. Can you afford the move? Or I guess you could also say, can you afford not to move? So my name is Jerry Festa. I head up product marketing here at Zscaler, and I'm joined here by Steve Howes, who's the VP or Vice President of Product Management at Zscaler. In today's session, we're going to talk about the move or on-premise versus cloud security. And I couldn't think of a better person to basically deliver this presentation than Steve. Steve comes from a long history of appliances and has since seen the light. I guess he's been at Zscaler for a little over 2 years now. And you know, when I had a conversation with Steve, we've had a number of discussions between cloud and the appliance world. So I think Steve is best positioned and best situated to give you a view, an unbiased view from both worlds. So with that, I'd like to get started. You know, technology continues to evolve, and it's evolving on a constant basis. But every so often, there's a shift in the technology. Some people would say that shift takes place every 10 years or every decade or so, and we've seen that shift, you know, looking back to mainframe, to client server, internet mobility in the late 90s, early 2000s, and now to the cloud. But it's really the combination of the internet, mobility, and the cloud that's creating a mega shift, or something we consider a mega shift. And when these mega shifts take place, they create new business opportunities, they create new leaders, they create competitive advantage for those organizations that can embrace that technology or that shift. But for some organizations, it could lead to more of a challenge. So when looking back over the last 20 years, we took a look and said, okay, what did the Fortune 500 companies, what did that makeup look like in terms of companies that comprise the Fortune 500? And that was 20 years ago. And you fast forward to today, and you can see that over half of the Fortune 500 companies from 20 years ago were not able to make that shift. They were not able to pivot. Their businesses or their organizations weren't agile enough to pivot to basically what they say would cross or jump the chasm. For those select few that were, they became very successful. But for those who couldn't, found it very challenging. So I don't think anybody would argue that the cloud is happening today. Well, you may have a few out there saying the cloud will never happen and they'll never embrace it. But a lot of the cloud adoption is driven by the IT organization as they shift workloads to Amazon or Azure, as they look to roll out Office 365, which are all kind of IT-initiated moves to the cloud. But there's a whole other flip side to that equation. It's when you start to look at users who are adopting cloud services, it's just way too easy. It's too easy for the marketing organization to go and say, we need Asana, and procure that services outside of IT. It's too easy for product management to say, I need to share these files with a vendor or a partner, and since they can't send them via email, we'll go and open up a Box account or a Dropbox account or use Google Drive, possibly even their personal account, to share those files. And it's created a significant challenge for IT organizations to secure this cloud environment, and it's really disrupted over 30 years of networking and security. So when you think back about how networks were formed, the corporate network was really the center of the universe. And it started off very simple, but over the course of 25, 30 years, the level of complexity increased as we continue to add compute, as we continue to expand these networks, and they became a little bit more complex into wide area networks. And then we had to secure those networks and deploy a bunch of different appliances. And that was all centered around, if you wanted to get access to an application, you had to be on the network because that's where the applications resided. But today, if you look, the applications have since left the corporate network, have left the data center, are moving to the cloud. Your users no longer need to be on that corporate network to access the applications. So if you were to look and saying that whole shift has completely disrupted in the network and IT security landscape, and it's becoming increasingly irrelevant. So if you were to start over, and you were, say, on one side you had your applications, whether it's in the cloud or in a data center, and you had your users and devices that you need to connect to those applications, how would you do it? Would you continue to go down that path of trying to secure the network? Or would you start to think from even a user experience perspective, from an agility perspective, how do I just securely connect the right user to the right application using the right policies? And can I leverage the competitive advantage afforded by the cloud, the scale, the economics that the cloud delivers? And that's what we're going to hear talk about today. But when you rewind back and start to think about how all this evolved, and we built a perimeter around our corporate network, and that was to protect it. And then we had to open up that perimeter to the internet. Some people would say it's kind of the castle and moat security architecture, and the internet gateway served as a drawbridge out to the internet. And to secure that corporate network, we deployed a bunch of appliances: firewalls, URL filters, DLP, SSL, sandboxes, and that's just today, right? And that list continues to go on, and in conversations I've even had with customers are saying that's probably about half the stack of appliance that we have from a security perspective in our own gateway. On the flip side of that equation, you had your users becoming mobile, so you had to kind of expand, I guess you could say loosely say, the DMZ to now include an inbound gateway to allow remote access to the, basically you're giving remote access to the corporate network or extending the corporate network out to where that user is located. And to do so, for larger organizations, they had to deploy global service load balancers to properly route the user to the right location. Since you're opening up your network to the internet, you obviously want to protect yourself from attacks, so you deploy some DDoS services or a DDoS box. You deploy your firewalls, your VPN concentrators, and you load balance across your applications. And all that was to open up your network to the internet in a secure way and provide remote access to that corporate network. But the world's changed. And we've taken that infrastructure and we replicated it out across all major geographies, right? And we eventually established a perimeter to protect that corporate network, to protect the LAN, protect the WAN, protect all our branches. And all that traffic was routed back across and out these centralized egress points. But as users became mobile and your applications moved to the cloud, and really kind of questions what you're protecting now with perimeter-based security. And if you look at a quote from GE, they have a heavy push to move over 70% of their workloads to the cloud. Modern applications like Office 365 were built to be directly accessed via the cloud and not to be backhauled over traditional hub and spoke architectures, and that's from the latest guidance from Microsoft. And as more workloads and as more of your applications move to the cloud, the internet has essentially become part of your corporate network. Or some would say in the future, like Siemens, who's a little bit more progressive thinking, is saying, look, by 2020, we want the internet to be our corporate network. And that's not just going out over plain internet connections from your offices. That also includes standard broadband, LTE connections, Wi-Fi connections. So basically, treating network transport as agnostic. So to do so, they need to think of a new way of connecting users to the applications in a secure manner. And the whole concept of deploying these appliances was to protect the network and establish a security perimeter. But now that you're opening your network up and more workloads, and the internet is becoming your new network and you're sharing it with over 30 billion strangers, how do you secure a network, and how do you secure a network you don't control? And is that whole concept of securing a network even relevant in today's world? So this is where the cloud comes in, and it's saying the shift away from the old model of hub and spoke and backhaul and MPLS and VPN to the new world where you're going direct to the internet, and your security model is more around policies that securely connect the right user to the right application or service over any network. So we've talked about kind of this drive towards the cloud, and I think every vendor and even every existing vendor who came from the appliance world is all talking about cloud today. And there's a reason for that. If you weren't talking about cloud and you had to report up to the board, you'd probably lose your job. But beyond that whole shift in the market, there's a bunch of other drivers, a lot of financial drivers behind this shift to the cloud. And I'm going to turn it over to Steve House, who's going to talk about, so what's next? Like, how do you make the business justification to the board to move to the cloud? So with that, I'd like to turn it over to Steve.
Thank you very much, Jerry. Well done. That was very insightful. So when we take the topic of can you afford to move to the cloud, we look at a few different areas of costs around running your network, running your security, and starting with security, really the costs fall into three major buckets. First, there's the infrastructure you need to put in place to do the security, to have your tools, to find those threats. There's the time that your organization spends maintaining that infrastructure, and then there's the cost of the unknown threat. When something does get through and causes a problem, there's a cost to your organization to clean that up. So all of those have to be considered when you're talking about the total cost of running your infrastructure. When you look on the surface of buying your internet security to replacing that DMZ like Jerry talked about with a cloud solution like a Zscaler compared to just going the traditional path and buying more appliances that you always have, when you first look at the cost and say how much does it cost to procure this versus that, it might look similar, but when you really think about the costs over time, there's a few things that looking at the appliance tends to leave out of the mix. First of all, your traffic continues to grow. Here we say internet consumption is growing at approximately 20% a year. I can't tell you how many customers I've talked to that are growing greater than 30% a year, which means whatever you sized your appliances for, in the next 2 to 3 years, you're going to have to double it because that growth starts to compound. You also start to enable more and more features on those appliances, and every time you do that, and SSL decryption is one of the key ones that everybody should be doing right now. You need to be inspecting that encrypted traffic because that's where a lot of the nastiest threats are hiding. But every time you turn on a feature like that, you scan more content, you inspect more SSL, you're adding load onto those appliances and taking what used to fit and work, and now it's starting to run into performance problems. You also have the cost of your MPLS. If you're deploying appliances, you're probably doing it just in a handful of egress points, and that means all of your growth in internet traffic is also crossing your WAN. So you need to think about the WAN upgrades you're going to have to make every single year just to keep up with that extra traffic on the network. And if you're following Microsoft's recommendations, then you start to think, I need to break out my traffic as soon as I can and get it onto the Microsoft network as soon as I can, because that's the recommended architecture that Microsoft's pushing really hard for Office 365. And the reason they're doing that is it's the only way to get the performance that users need to have a successful Office 365 deployment. And then you go into year 3 and it all repeats again. one more thing about Office 365 is if you are running all of that through a set of appliances, you not only have to look at the performance in terms of can I process that much traffic, but you also have to look at the connection load, because the average user of Office 365 might have 20 to 25 open TCP sessions, while a non-Office 365 user might have about 5. And with that load, you could overrun any secure web gateways, IPS devices, next-gen firewalls. Any of those things could be completely overrun, which means that's more upgrades you have to do just to support what's going on. Then you think about the managing that infrastructure. This is a really interesting chart about, by industry, how quickly do vulnerabilities get patched, and how effective are they after 12 weeks. And you can see the rate of patching varies widely, everything from education, that after 12 weeks, or about 3 months, is only 18% of the organizations have patched, to some that do really, really well, like IT and manufacturing. But the interesting thing is, even the ones that are doing really well are taking 6-8 weeks to get near those 90%. In fact, they're taking a few weeks before you're even to 75% of those companies that are patched, which means there is a window of opportunity for the bad guys to take advantage of vulnerabilities. So you have to think, I've got all of those appliances out there. The more complicated my environment is, the more time I have to spend figuring out which devices need to get patched, how do I patch them, how do I make sure that these new vulnerabilities aren't exploited by the bad guys that are out there. When you look at Zscaler, another thing that's really important is that we have a worldwide footprint. This map shows our public data centers, and the ones in red are the ones that we peer directly with Microsoft. So wherever your users are around the world, you can get out to the internet quickly. You don't need appliances there to do it. You don't have anything to patch and monitor, and we peer not only with Office, but over 150 other content providers, things like Amazon and Google, as well as all of the Tier 1 service providers we peer with around the world as well. So you can go directly from the local service provider that you know and trust into Zscaler, into those content providers. Something really important to go back to that point about patching of appliances is, because of our cloud effect, when we find a threat, we instantly protect you across the entire cloud. All of our 15 million plus users, over 5,000 organizations get that advantage. In fact, we do over 120,000 security updates every single day to make sure that as soon as something is found, you're protected. We completely take away the cost and delay of trying to patch your own infrastructure. When you look at the infections that are happening, according to the Verizon Data Breach Report, 93% of breaches are measured in either seconds or minutes. The breaches happen very, very quickly. Now, it takes a few days in many cases before the exfiltration happens, but still 98% of the exfiltration happens in a measurement of days or less, hours, minutes, and even seconds in that case. So if you're having that major delay between a vulnerability being announced and made public to the world, which includes all the criminals, and the time that you're patching your appliance infrastructure, that could be way too late. As I said, only about 70% of the good industries had their environment patched within a few weeks. A few weeks is too late. If an exploit comes out, people take advantage of it. That is way too long where you're exposed out there in the world. The middle section here talks about the types of activities where it involves credentials, and they have stats like 63% of confirmed data breach include weak, default, or stolen passwords. 75% of them, though, were done within a day. That means if you're not patching quickly, you have yourself at risk, and the average cost of a breach has now exceeded $4 million. And you can imagine some of the big ones like Equifax's is going to far exceed that in all of the remediation that they have to do, and that doesn't even count the impact to the brand when something like that happens. So when you start looking at what Zscaler is able to do in terms of the skills gap, the people to actually monitor, run, maintain, and provide that security within your network, we offer a number of different points in the kill chain where we can identify and block potential threats. When you look at the kill chain, it goes everything from creating the malware and doing reconnaissance to finding the way in, delivering the payload, exploiting the known vulnerability, installing the malware onto the device, and then you start exfiltrating data out to the command and control site. Before that, you connect to it, you get instructions, and then you send your data out. With a full stack security as a service from Zscaler, we can prevent everything from the delivery. We have SSL inspection. It's very flexible and policy-based. It allows you to open up as much or as little of the SSL as you want. We obviously recommend the more you can open by policy, the more safer you're going to be. And then we can do full scanning of everything inside. First of all, we're not even going to let you get to a known bad site. We're going to scan all of that content through every one of our engines, the antivirus engines, the advanced threat signatures, the browser controls, looking for things like cookie stealing and cross-site scripting, providing a risk score to every site based on what we know about it, what we've seen in the past, and if we've really never seen a file before, none of our 15 million users across our 5,000 organizations had ever downloaded a file, we're going to send that into a sandbox and see what happens. All of that is about trying to avoid getting infected. But let's say you do get infected. Maybe you get through all those defenses, but maybe you brought it in on a USB stick, maybe it came in over email separately. When the malware gets installed, the first thing almost every piece of malware does is do a call home to get another payload or get instructions from a command and control site, and that's another opportunity to see that they're going again to a known bad site. We'll block it right at the URL or the DNS level, or to run all our signatures against it again, saying this matches an advanced threat signature of a botnet that's calling home. And then finally, if that doesn't work, if they're getting it out some other way, the last thing is there's full DLP built in. So if you have social security numbers or account numbers or driver's license numbers, financial statements, healthcare records, or even anything just marked company confidential, internal only, do not distribute, we can see that going out. Again, it's often encrypted, but if you're doing SSL inspection, we can see it going out, and by policy, we can either alert you, maybe it is allowed, maybe it's going out to Box, and Box is your corporate file storage, or we can inline block it. We can say, you know what, we see 10 Social Security numbers or more than 10. We're going to block that right now and make sure that it doesn't get out of the network, and we're going to alert you to go see what's going on at the same time. Another thing that's really different in an appliance world versus a cloud world is that you can apply a policy worldwide and have it implemented in seconds for every user in every location. This could be whether they're at a branch office that's getting their traffic sent to Zscaler, or a roaming user who's on vacation but doing some work while they're in Australia. The policy is set centrally, it's instantly deployed, it's available worldwide, it follows the user wherever they happen to go, and you don't have to worry about something that you've learned that is a policy you want to apply and having a delay to get that into production because you have too many devices, too many places, or you've got change control windows you have to figure out. It's instantly applied worldwide. And then the other thing that's very different is no matter where that user is, what site they're coming from, whether they're roaming or in a branch office, they're instantly getting that data back into our admin UI to do full reporting, to provide visibility into the apps they're using, the sites they're going to, the threats that have been blocked. All of that is available within a few seconds of any transaction happening. You don't have to manipulate logs, move them around, batch transfer them. So you're getting full instant global visibility. Zscaler's stack provides all of the functionality that you would find in a typical DMZ to do cloud firewall, to do URL filtering, bandwidth control, all the threat protection technologies including sandboxing, and the data protection technologies like DLP. If you look at the state of the art in 2010 about how you might go about building a cloud, the way that Zscaler approached it was to say, can we leverage some of the technologies and tools that are out there already and build something that could provide this level of capability for customers? Because as Jerry said, the users have left the building, the apps have moved to software as a service or to infrastructure as a service, and it makes sense to put that security stack between where the user is and where the resources they're accessing are. So we looked at things and said, how might they scale? How might you put it together? Starting at DNS, that scales really, really well, 100 terabits per second. Next-gen firewalls scale pretty well. The highest end ones can get up in the 100 gigabits per second if they're not doing much else, just passing the traffic through. Your IPS is more like 10 gigabits per second, but then you start looking at things like your SSL proxy, which is measured in 100 megabits per second. If you start doing full AV of all that traffic, in 2010, that was about 10, 15, 20 megabits per second. And if you wanted to do DLP, again, it's about 10 megabits per second of scanning on the way out. And if you wanted to do a sandbox, that's out of line and takes 1 to 5 minutes to analyze that. So you start looking at the mess of appliances. It starts to look like some people's DMZ, like Jerry showed earlier, the 30 years of networking. But each one of those hops to do a separate function adds latency. Millisecond here, a couple milliseconds there. It also adds complexity. I've got to figure out how to load balance and track my flows back through. They've all got their own control, enforcement, and logging. Each one is done separately. So if I want to set policies, I end up having to set them on every one of these solution layers along the way. I get different logging. I have to bring it all back together into some reporting. And how do you scale that to 40 gigabits per second? That's what a decent-sized cloud POP has. In fact, our largest data centers are now dual 100 gigabit per second in and out of our cloud POPs, because that's the kind of scale you need when you're building a cloud service to service 5,000 organizations. So how has all this changed in 2017? With the advent of SDN and network function virtualization, virtual network functions, all of the DNF, all of that, sure, that makes it easy. It's helped scale the horizontal. I don't have to ship millions of boxes around the world. But the fact is the complexity and the latency through that network hasn't changed. Each one of these is still fundamentally built to be single tenant. They have separate control, enforcement, and logging still. The policy objects aren't shared amongst them, and the user experience is going to be bad because you've got the latency just getting through your system, and whenever anything goes wrong, you've got to troubleshoot where along this path did that problem happen. So when you think about, can I really repurpose all of that into the cloud, we like to build the analogy of, would you ever take 1,000 home power generators and create a power plant on it? No, that's not the way anything ever built. That can't really scale. You need to think about from the ground up, if I'm going to build something to service thousands and thousands of customers and millions of users, how would I do that from the ground up? And that's where Zscaler's architecture comes into play, designed from the ground up to be a multi-tenant cloud service with separate control, data, and logging planes. The control plane we call the central authority. That's where all the policy is kept. That's where it's distributed whenever a user shows up in any location around the world. If they've never been seen before, it asks the central authority for their specific policy to do the enforcement, and no matter where they are in the world, all of their logs come back to their specific logging cluster, which is in the part of the world that they designate, either the European Union or the United States.
So Steve, while we're on this, there's a question that came in that said, is the user required to have an agent on their system then to get the policy updates? And I think you can think about that question in two areas. The first one is a traffic forwarding. So from a traffic forwarding perspective, you have a number of different options. You can set up a GRE or an IPsec tunnel from your offices for your mobile users. You can use a pack file for your web traffic, or we have a lightweight traffic forwarding agent that can run at directs traffic to the nearest Zscaler cloud. And the second part to that is around how the policy or the policy object. And I thought this was a good place to stop, because when you look at the architecture and you look at the control plane, this is what we call the central authority. And that's where you define your policies. So when a user connects to one of the enforcement nodes, their policy gets downloaded or pushed locally. It is truly a multi-tenant or inherently a multi-tenant system. So when I connect, a policy gets pushed down to that local Zscaler enforcement node where my policies are enforced. When a policy update happens, that session gets expired and it will automatically download on the very next GET request a new policy object, and that will get enforced no matter where I connect. So if I connect today in New York and you change the policy, and it will automatically be enforced on the very next GET request. If I go to, let's say, Singapore tomorrow, that same policy object gets downloaded and enforced locally in Singapore. So, anything to add to that, Steve?
Yeah, thanks, Jerry. That was really useful. I think one of the fundamental difference that to contrast what Jerry just described to what some of the other appliance vendors who have built a cloud service would be, is that they are going to provision users into towers. Sometimes they even use that language. You're in this tower, which means they're going to set you all up and get your policies configured at that specific tower, which I think is appropriate because that's kind of what it looks like on the left, a tower of boxes that is put for you. At Zscaler, we have no such concept. It doesn't matter to us whether a specific node, and again, that mess of 20 boxes you see at the left is exactly one box with multiple virtual instances inside it that all do the same thing, all in one instance of RAM. So the load balancing is done in the same box and sent to the specific node, and that node will open it once, and it will send it to all of the engines, not a bunch of different appliances. There's no service chaining of one service to the next service to the next service. It's all sent in parallel. A verdict is given. This is both within policy and safe, and we allow the flow to go through, or it breaks some policy or turns out to be a threat, and we block it, and it's closed up and off on its way. So the architecture is very different. So for us, it doesn't matter if one box instance has 20,000 users from 20,000 different companies or 20,000 users from the same company. It's the same scale. It's the same policy object. A policy object is always down to the user, has nothing to do with the organization. That just so happens to be part of the policy that they got. It's a fundamentally different way of approaching how to build a multi-tenant cloud service. To give a couple of examples of some customers who have gone through this transformation, we'll start with a company called Kelly Services. They had 650 locations on MPLS and decided they were interested in moving to an internet-only branch and trying to figure out what that might be. And they figured out that Zscaler can provide them everything they need, including a full outbound firewall protection. And they took those 650 locations on MPLS, and now only their 30 largest sites have MPLS. The rest of them all just use the internet as the WAN. They've got no appliances out there. They're just have a little managed service from AT&T where they built a tunnel from their branches to our cloud to manage all of the forwarding. And they were able to successfully deploy not only Zscaler for their internet security, but this helped make their Office 365 deployment successful. They went to the directly connected branch even before Microsoft recommended this. Microsoft changed the recommendation in May of 2016 to break out as soon as you can and not try to use ExpressRoute with Office 365. Kelly Services did that model before that and maybe even helped influence Microsoft to show them how well it performed. And the other thing that's really interesting is once you break out all those branches, some of them don't have that much bandwidth, and they allow things like YouTube. And for the first time, they were able to have YouTube not be their #1 app on the network. They throttled it down to no more than 20% of their link, and they reserved 40% of all their bandwidth for Office 365. So it got the bandwidth it needed even at the smaller congested branch offices. Another good use case is Siemens. Jerry showed you the quote earlier about how they want to completely get away from this notion of securing the network and move to securing the user and having internet only as a long-term vision where they don't have any more wide area network, but they were immediately able to reduce their MPLS or avoid upgrades on their existing MPLS by 30%, more than paying for the entire cost to implement Zscaler, and at the same time they saved all that money. They improved the user experience because everyone's getting to the internet right away, and about 85% of their traffic that was crossing the WAN turned right back around and went out to the internet because it was either general internet or more than that, it was the Office 365 and Salesforce and other SaaS applications. And they did all of this while improving their security posture as well. And then finally, AutoNation, which is the United States' largest auto dealership. they were able to take their 270 retail locations, and again, they were looking at deploying redundant firewalls at every one of those. So that would have been 540 branch firewalls that they would have had the size large enough to do SSL inspection, which meant they bumped up a model or two, and they would have had all that hardware to manage and realized, wait, if they just forward to Zscaler's cloud service, use the outbound firewall functionality and the full threat protection, they could completely simplify everything that they needed and do it in a way that was much less costly for them. And the entire deployment was just 2 months, and whenever a new dealership comes on, they just forward to the cloud and the policies are already there. A lot of people get a little bit shy and scared about how do we make this transition from a backhauled world through a mess of appliances to a cloud-enabled secure environment. And Zscaler recommends a 3-step transformation journey. Some customers start on step 2, some start on step 3, but it's easier to start on step 1, which is first, up-level your security. You can take whatever your existing infrastructure is and just forward your traffic onto Zscaler. You set up the policies, you get familiar, you know it's providing the protection that you need. Then, over time, which again, usually the difference between step 1 and step 2 is not very long, it's measured in weeks or months, you then start to simplify your environment. You start removing those appliances when their support renewals come up or the hardware refresh comes up. You might start with your secure web gateway and then your sandbox and then your DLP, and all of a sudden you've got a much cleaner, simpler environment. Everybody's got the same policy applied. And the great part about getting here is now you can get to that network transformation world where I'm taking my branches and I'm directly pointing the internet traffic to the cloud, either using SD-WAN. We integrate and partner with every SD-WAN vendor out there to do the forwarding to us, or just off your existing router infrastructure there, you can build a GRE tunnel directly from those branches. And the reason that a lot of customers don't start with Transform is because that's the one that takes time. I've got to get the networking team fully bought off. I've got to make sure I've got the internet circuit out there. I might be working with the service provider who's running a long project. And the great part about starting in number 1 or number 2 is if you get the security layer in place, the move to point over the MPLS versus to point to the internet directly has no change at all to your security policy. You are just instantly saving money and improving the end user experience at the same time when the security is already in place there. And that's why if you get the first part in place, the transformation at the end becomes seamless. So with that, I'll turn it back over to Jerry to talk about a few other things you might be interested in and to get to any questions that may have come in.
So look, we mentioned Siemens a couple of times, and for those of you who are a little bit more interested in diving a little bit deeper in Siemens' directions in terms of their thought leadership around adopting the internet as their corporate network and using LTE, broadband, and the such in lieu of MPLS, or only using MPLS where they need to. There's a webcast out there. There's a recording from RSA that you can go ahead and listen to. We did have some questions come in, so I want to get on some of those right away. The first question is around hybrid. So I'm going to take this, and it was around, a lot of organizations are talking about hybrid approaches to security. And look, it's a very simple answer to this one, but I'll probably make it more complex than it needs to be. The simple answer is it's a cop-out and basically a tactic used by a lot of the appliance vendors to continue to sell more appliances for they don't have a full cloud service that can handle all your traffic and do everything you need it to do to enable this transformation. and to actually replace their appliances. They're stuck in a really tough position. And the way I like to think about it, the word hybrid is completely abused by marketing organizations. I look at hybrid networking, where you have a combination of MPLS, you have a combination of broadband or internet, you have a combination maybe of some VPN. That makes sense. I look at hybrid applications. You have applications sitting in your data center, you have applications moving to SaaS, you have applications moving to public clouds like Azure or AWS. Completely makes sense. But to take a single instance or taking an atom and splitting an atom does not make sense. And where I'm going with this is, if you were to buy Salesforce, would you also deploy Salesforce on-prem? And I guess the analogy, you wouldn't do it. If your cloud-based service is good enough to replace what you have on-premise to deliver you better security, more agility, cost savings, and enable you to kind of gain a competitive advantage by transforming, why would you compromise and keep making that investment in legacy, right? It would be like buying a hybrid car when you can get a higher performance Tesla out there at the same cost, gives you better range and better performance, assuming it was potentially at a better price. So look, there's those compromises, and so when thinking about hybrid security, it is a ploy, and I highly recommend when you look into that hybrid architecture, do a deep dive and say why, and question why do I really need some of these appliances on-prem. There's another question that came in here, and Steve, it's regarding a competitive offering. This one, I kind of don't like to do this on a webcast, but we currently use ScanSafe. How would your solution compare to, let's say, ScanSafe or a similar product?
Yeah, there's the high-level generic answer, which is Zscaler, again, that was built as an entire internet security platform. It does way more than just URL filtering. I think even the way the question's worded here, it was like they do our web filtering. That is what a ScanSafe and a lot of the other SWG vendor cloud offerings were built to do. Zscaler was built to replace that entire security stack. Just a little bit of a dig on ScanSafe. Cisco is formally ending that, so that whole offering will go away. So that's another reason why you don't want to be on that long term. And Cisco's approach now is towards their OpenDNS umbrella, which is essentially trying to make all the decisions based on the DNS, which is fundamentally a security trade-off for the ease and scalability. They tried to build a cloud like we showed before. ScanSafe had those typical towers, and they could never make a profitable service because there was too much hardware and complexity to build a cloud that actually could deliver at the scale that a cloud needs to deliver at.
Yeah. We have another question that came in. How do you handle, how do you address data sovereignty requirements and legal regulatory requirements for companies, let's say, based in Canada, or for that matter, let's say, Germany?
Yeah, the best way would be if you go back to that architecture drawing that we have. We have our Zscaler enforcement nodes in the 100 data centers around the world, but it is important to note that at that enforcement layer, we do not write anything down. There's nothing written to disk at the enforcement layer at all. Everything is done in RAM, it's analyzed, it's, as I said before, it's either allowed and passed on, and we allow to deliver the file down or send the file up, or it's blocked. That architecture is very unique. There's not even a log written locally. The logs are also tracked in RAM, and as soon as the flow is over, that log is sent where it needs to go. We store the logs in a few hub data centers. You can specify whether you want those in the European Union, which is what our default is for all of our European customers, and even some multinationals based in the US choose to store their logs in Europe because of the rules for the storage there, and in extreme cases, we even allow that logging infrastructure to be on your premise if you're large enough and have that strong requirement, but that is usually not the case because our architecture is such that we do only store a very minimal amount, and you can direct where it's stored from. And as you can see, we've got large companies like Siemens and Henkel and Schneider Electric in France and Nestle in Switzerland. So these are highly privacy-centric countries and very large companies that have vetted our architecture and said that we understand privacy. We can do things in the UI like obfuscate the usernames so the admins can't even see who it is they're looking at. They just see a token. All of that's done to maintain the privacy of the end users and make sure we're allowing companies to be in compliance with their local regulations.
Yeah, and specific to Canada, we do have a number of very large organizations in both financial services and insurance companies that run on Zscaler, and we can address their privacy concerns without a problem. So with that, we'll keep it open for a few more minutes here to answer any last-minute questions. And one thing I do ask, if you're still on the line as more questions come in, if you could just be sure to fill out the survey at the end of this, just to give us some feedback. Always looking to improve how we deliver information. So Steve, there's another question that kind of came up. Person missed the first half of the presentation and said, look, if you were to just summarize the difference between cloud versus on-prem, how would you summarize it? And I can take a stab, just thinking freely here. I would say the first thing is, look, just the market's changing, right? The concept of protecting your network with appliances in a cloud and mobile-first world is becoming increasingly irrelevant. The second thing that Steve kind of touched on was the cost and complexity, and this is just the amount of money spent building and trying to maintain all these appliances, the infrastructures, and with each new threat type, you have to deploy another appliance, and can you really afford to keep up with the pace that new threats are emerging? There's a security efficacy part in here that we touched on, and that's in terms of, can you patch your systems fast enough? Can you afford to buy enough appliances to inspect all of your traffic? A lot of times what you'll see, if you do kind of the generic side-by-side checklist comparison, can I do SSL? Yes. Can you inspect the separate traffic? Yes. But what happens in appliances is when you make these decisions in terms of, okay, well, let's say I want to inspect all traffic. Well, that's going to take a big hit on the performance. Let's say I want to inspect SSL. That's an even larger hit on performance. So look, it's a lot of times only suspicious traffic gets inspected, and that's a risk that you can't afford to take. Once you say, hey, this is coming from a trusted domain like the BBC or CNN or the Jay Leno pages or one of those, and it's all based on reputation, you've opened up yourself, you basically opened up and exposed yourself to attacks, right? And the difference between the cloud and the on-premise world is the cloud inspects all your traffic and backs it up by an SLA. So there's no trade-offs between good and bad. It's all bad, it's all inspected, it's all scanned, and that includes SSL. And the other, I guess I'd say the last one was about user experience, right? Service chaining all these boxes together and multiple hops through them, and there's no correlation. All the boxes run in isolation, and each of those hops introduces latency. Each of the network segments introduces latency, and that latency impacts the user experience. So when you're looking, and this is one of the primary drivers behind Microsoft's recent recommendation, is to go direct, right? They don't want this latency introduced because it will break certain applications. So if I were to sum it up, those would be the few points that I would hit on, Steve. I'm not sure if you want to add to that?
No, I think you got them all.
Okay, there is a question here. We'll be getting a copy of the recording and take some presentation. Yep, so we will definitely make the presentation available. The recording will be available. And if anybody does have any additional questions, you can feel free to reach out to me directly, go ahead and email me. I'll do my best to get back to you as fast as possible. My email address is gfesta@zscaler. If you have additional questions or you need additional information, or if we can be of any assistance. So with that, I would like to thank you all for taking time out of your schedules to join us here today. Hopefully you found it useful, and please, looking forward to reading your feedback. Have a great day.
Yep, thank you everybody.